Okay, we're going to go ahead and get started on the next free response question. So we have a Taylor series for a function about x equals 1. So again, we see this x minus 1. So this is a Taylor, not a Maclaurin. This converges to f of x for x minus 1 is less than r, where r is the radius of convergence. So they want you to find the radius of convergence. So we're going to need to use the ratio test, get the IOC, and from the IOC we'll get the radius of convergence. So we're going to take the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so this is going to look like minus 1 to the n plus 1 plus 1, 2 to the n plus 1, x minus 1 to the n plus 1 over n plus 1 divided by the original, minus 1 to the n plus 1, 2 to the n, x minus 1 to the n over n. Flip the guy and simplify. So this becomes n plus 2. So we have minus 1 to the n plus 2, 2 to the n plus 1, x minus 1 to the n plus 1 times, we're going to have an n here when we flip, and I have n plus 1, and the other stuff in the bottom is going to be minus 1 to the n plus 1, 2 to the n, x minus 1 to the n. Okay, and now we're going to work on simplifying some stuff. Ooh, sorry, you couldn't see that over there on the end. And I need an absolute value sign. Okay, so we're going to simplify this and this. It leaves us with a 2 in the top. So we've taken care of that. I'm going to simplify this and this. That's going to leave me an x minus 1 in the top. So I have an n plus 1. And then when I compare the minus 1 to the n plus 2, minus 1 to the n plus 1, that leaves me with a minus 1 to the first power. So now I'm going to start moving things around. Anything not involving the n, I'm going to bring to the front. So this times this becomes minus 2 x minus 1 equals, and then, sorry, the limit as n goes to infinity, the absolute value of n over n plus 1. So we know that this is going to go to 1, and we need to multiply that by this absolute value. I'm going to distribute. This becomes minus 2x plus 2 has to be times 1, has to be less than 1 to get convergence. So now I'm going to work on this inequality, rewrite it without the absolute value signs, minus 1 less than minus 2x plus 2 less than 1. Okay, I'm going to subtract 2 from everything. So that gives me minus 3 less than minus 2x less than minus 1. And now I need to get x by itself. Divide through by minus 2. Remember, that's going to flip the signs. So I've got 3/2. That becomes greater than x. That becomes greater than 1/2. And rewriting in increasing order, look, the inequality looks like this. And recall you're asked to find the radius of convergence. So the difference between those is 1, so 1 divided by 2 is 1/2. So the radius is 1/2. Okay, so we've answered the first question. B asks us to find the first 3 non-zero terms and the general term of the Taylor series for f prime. So we don't even have any of these terms of the original series written out, so we may not need to do that. So let's write out the first 3 terms of f of x. So plugging in n equals 1, n equals 2, and n equals 3 into this, when n equals 1, minus 1 squared is just 1. So then I've got 2 times x minus 1 divided by 1. So that's the first term of f. And then when n equals 2, this is a negative sign. When n equals 2, that is 4. This becomes x minus 1, and that is squared. And that is over 2. And then we're going to do n equals 3. That is minus 1 to the 4th. That's a plus sign. So 2 to the 3 is 8 times x minus 1 cubed all over 3. So now we're asked to, we only need the first 3 non-zeros. So if I have 3 of these terms, let's try to see if that's enough to give me f prime. So take the derivative of the first term, it leaves me with a 2. If I differentiate this term, I multiply by the exponent, subtract 1, derivative of the inside. So 2 times this, these 2's are going to cancel. This becomes minus 4x minus 1 to the first power. The derivative of the inside is 1. And now differentiating this term, we're left with 8x minus 1 squared. So that answers question 2. Finally, question 3 says, the Taylor series for f prime about x equals 1 found in part B is geometric. Find the function to which the series converges. Okay, so just like before, they told you, well this time they told you it's geometric. So if I take the ratio of this term and this term, I find that the ratio is minus 2 times the quantity x minus 1. So if I want to generate the function, I take the first term over 1 minus r. This becomes 1 plus 2x minus a minus minus becomes a minus 2. And if I simplify further, this is 2 over 2x minus 1. Use this function to determine f for x minus 1 less than r. Okay, so really, maybe I should have called this like g of x or something. That's fine. So I got a function. This is really f prime, and I shouldn't have wrote it. So now what I need to do is, if I want a function for f, I have to integrate this. So I'm integrating 2 over 2x minus 1 dx. Okay, so I have to use u substitution. U equals 2x minus 1, du dx equals 2, so du is 2 dx. I have 2 dx, so this becomes du, and this is u. So f of x is going to equal the natural log of 2x minus 1 plus c. So I have to solve for c, and you should always do this. So you want to pick a value of x with a known answer. So if I let x equals 1, so f of 1 would be the natural log of 2 minus 1, or 1. And I know that that is plus a constant, and this has got to be equal to 0. So that means my constant is equal to 0. So my final full credit answer would be the natural log of 2x minus 1. And this is true only on the radius of convergence. So you could write it like this, or you could write it like this. Either one is correct. Okie doke. That finishes that one. Let's move on to the next one.